Hello everyone and welcome back to these sessions on quantitative methods for CFA Level 1. Now in this class we are continuing with the topic testing of hypothesis, and in this particular class we are going to explore more examples to have much clearer understanding about stating the hypothesis, identifying the critical regions, identifying the type of test involved, whether it is one-tailed or two-tailed test, as well as something about the significance level as well. So let us start reading the questions. Here we begin with example number 7. Let us read this example. A financial analyst is evaluating the performance of a particular stock. The company claims that the average dividend yield of its stock over the past decade is 4.5%. However, the analyst suspects that the actual average dividend is greater than the claimed 4.5%. To verify this, the analyst collects data from the last 50 dividend payments and decides to perform a hypothesis test at 5% significance level. Required: state the null hypothesis and alternative hypothesis, identify the type of test, that is one-tailed or two-tailed, and determine the rejection regions for the test. Now, how are we going to approach the entire example? That is something that you have to understand very well. You notice one thing that we have learned earlier, a step-by-step procedure. The very first step is the most important step, that is stating the hypothesis, where you have to state a set of two hypotheses, the null and alternative hypothesis. Now, what have we learnt already? Never begin with stating the null hypothesis first. You will go wrong if you do that, because look at one thing. The company is claiming that the average dividend yield of the stock over past decade is 4.5%. This is the company's claim. Somebody could have made a counter claim that no, your dividend yield is not equal to 4.5%. When a generalized statement like that comes, that dividend yield is not equal to 4.5%, means it could be greater than 4.5% or it could be even less than 4.5%. That means it will result into a two-tailed test. Correct? It will result into a two-tailed test. Now, never decide anything about hypothesis and the type of test based on the null hypothesis. Never initiate with null hypothesis. That is lesson number 1. What you need to do, look at the suspicion made by the analyst. The analyst suspects. So what is the suspicion? The actual average dividend yield is greater than claimed 4.5%. That means analyst is stating the alternate hypothesis as mu greater than 4.5%. Now and now only you can identify what will be the null hypothesis. If alternate hypothesis H1 indicates that mu greater than 4.5%, null hypothesis H0 has to state that mu less than or equal to 4.5%. If you just write mu equal to 4.5% as null hypothesis, it will be wrong, because both hypotheses taken together, it should cover exhaustively all possibilities. So there may be 3 possible scenarios, right? Mu is less than 4.5%, mu is equal to 4.5%, mu is greater than 4.5%. So the alternate hypothesis is picking what line? Mu greater than 4.5%. So null hypothesis has to include the other possibilities, that is mu less than or equal to 4.5%. Now, it is greater than 4.5%. So we understand one thing, that finally when you are stating the hypothesis, H1 which you decided first, H1 was what? Mu greater than 4.5%. H0 was then stated as mu less than or equal to 4.5%. Now you think and tell me, Think and tell me. Where would the critical region lie? When we are talking about acceptance or rejection, where will the rejection region come? Use your common sense. It will always be linked with what is the alternate hypothesis talking about. Alternate hypothesis is talking about the fact that mu greater than 4.5%. That is the alternate hypothesis. When I say greater than something, means is it falling on the right side or is it falling on the left side? That is again what you have to decide. So, if mu is equal to 4.5% or less than 4.5%, it will be null hypothesis. If mu is greater than 4.5%, it is alternate hypothesis. You have to always focus on alternate hypothesis to identify the complete clear scenario. Alternate hypothesis is stating that mu greater than 4.5%. Greater means greater will come on which side? On the right side. Keep in mind one thing, greater will always come on the right side, and you have to identify that this will be first of all a one-tailed test, and that too a right-tailed test. So let me help you with the approaching the solution part. So in your solution, you get started with writing identifying H0 and H1. So first you have to understand the claim. The company claims that the average dividend yield for its stock over past decade is 4.5%. This is the benchmark against which the financial analyst will measure their findings. So identify the analyst's suspicion. The financial analyst suspects that actual average dividend yield might be greater than claimed 4.5%. This suspicion suggests that they are looking for evidence that the stock has a higher yield than what the company states. That means based on these two paragraphs, whatever you are finding, you can see that the alternate hypothesis is clearly aiming at mu greater than 4.5%. You state that first, and based on the H1 what you have stated, you can find the balancing figure as H0. So do one thing, first you write this whole thing and then I take you ahead. Alright friends, once you have completed writing this much, let us move ahead and continue further. Formulating the alternative hypothesis. Since the analyst believes that the average dividend yield is higher than the company's claim, the alternative hypothesis H1 should reflect this belief. H1 should state that the average dividend yield is greater than 4.5%. So H1 will be mu greater than 4.5%. Then comes formulation of the null hypothesis. The null hypothesis H0 is the opposite of alternative hypothesis. It assumes that the company's claim is correct, meaning that average dividend yield is 4.5% or less. So mu is the average dividend yield is less than or equal to 4.5%. In other words, technically mu less than or equal to 4.5%. So please write up this as well and then I take you ahead. Alright friends, once you have completed writing this whole thing, let us move ahead and continue further. Identify the test type. Because the analyst is testing whether the average dividend yield is greater than 4.5%, this is a right-tailed test. Now determine the rejection regions. Significance level, that is alpha. Now significance level is given as 5%, representing the probability of rejecting the null hypothesis when it is actually true. Right tail test rejection regions. Since it is a right tail test, the entire 5% significance level is placed in the right tail of the normal distribution. So please write up this whole thing and then I take you ahead. Alright friends, once you have completed writing this whole thing, let us move ahead and continue further. Standard normal distribution. Now mu equals to 4.5%, that will be stated at the center because center indicates the mu. Now the critical region has to fall on the right side. So what we do is we put up a vertical line over here, and everything to the right of this vertical line will be the critical region. This indicates the significance level. Now when this center is stated as mu equal to 4.5%, if mu is greater than 4.5%, maybe a little bit greater, then what will happen? It is possible that it is greater, but it is not significantly greater. That means significantly greater would come in this region where I have shown the red markings. That means all these markings over here on the axis indicates the returns are, or the dividend yield, it is greater than 4.5%, but all these blue markings are showing that it is greater but not significantly greater. Red markings show that these are greater and significantly greater. Now if the mu is found to be 4.5% or less than that, you fail to reject the null hypothesis, and if it is found to be greater than 4.5%, then also you fail to reject the null hypothesis if the difference is not significant. However, if the difference is significant and falling on this critical region, then you will have to reject the null hypothesis in favor of the alternate hypothesis. So the blue shaded region will be the region that indicates that if the test statistic fall in that region, we fail to reject the null hypothesis, whereas this red region is the critical region. If something has to come here in the form of test statistic, then the null hypothesis stands rejected. Now this critical region, which indicates the level of significance, it is 5%. That means there is a 5% probability that we reject the null hypothesis even though it is true. That means the confidence limit that we have is 95%, which is lying to the lower side or the left side of this entire curve, the blue shaded region, which indicates 95% probabilities. Now we talk about the critical values. Now using the Z distribution, the critical value for a 5% significance level in the right tail is, now we don't know how much will be that unless we refer to the Z table. So let me do one thing. Let me stop over here and first take you to the Z table so that I will be able to explain to you what exactly will be the Z score where the level of significance for a right tail test is 5%. So let me take you to the Z table. Now as we know that this is going to be a right tailed test, and over here the critical region will be on the right tail. So let us assume that this is the critical region which we are marking as red. This is the region that we are marking as red. This is the critical region, and the blue region is the region where we will fail to reject the null hypothesis. So red region is the region where we will reject the null hypothesis, and blue region is the region where we fail to reject the null hypothesis. So you should always understand very clearly where lies the critical region. So here the critical region is lying on the right tail. Now the level of significance that we are considering over here, this area is going to be 5%. That means the blue region, what we find over here, is going to be 95%. Now from the Z table, we need to find the Z score for identifying the 5% cumulative probability. So let me take you to the Z table. We are observing a Z table where it is a cumulative area, that is a left tail area to Z. Left tail area to Z means we are going to get this area, the left tail area, and we want such a value over here for Z, that is we want the Z score over here such that the left tail area should be 95%. So let us observe it in the table. We need to find the value which is 0.95 in terms of area. Now look at this, 93, 93, 94. Now look at this, look at this particular part. I can find this zone that is 0.9495 and 0.9505. Between these two, what will lie is 0.95, correct? So where do we find these areas? In what value of Z? Look at the connection. It is in the row 1.60 and it is connecting the columns which have the column heading as 0.04 and 0.05. So we go to the row heading. The row heading will be 1.60 and the column headings are 0.04 and 0.05. So the combination will be 1.64 and 1.65. We need to find something between 1.64 and 1.65. So when we have to find something between 1.64 and 1.65, what we do is we will mention over here, we will write here the Z score for a cumulative probability of 0.95 will be between 1.64 and 1.65. So how do you compute it? You can take 1.64 plus 1.65 divided by 2, because it is exactly between these two. What you get is 1.645. So the calculation goes this way. Over here we will mention that this particular Z score marking will be positive 1.645. So if you want, for your reference, you may quickly take note of the same. And then we get back to our solution. So now that you have identified that the critical value will be the Z value, that is positive 1.645. So we have marked that value over here as a Z score 1.645. So do one thing, quickly take note of this whole description and then I take you ahead. Alright friends, once you have completed writing this whole thing, let us move ahead and continue further. Rejection rule. If the calculated Z value from the sample data is greater than positive 1.645, we reject the null hypothesis. This means that if the Z score falls into this extreme right region, it provides sufficient evidence to conclude that the average dividend yield of the stock is significantly greater than 4.5%. So please write up this whole thing and then I take you ahead. Alright friends, once you have completed writing this whole thing, let us move to the next example, that is example 8. Now here in this example 8, let me give you an opportunity to attempt the solution on your own and see if you can figure it out. My suggestion is do everything as a rough work. I am giving you exactly 5 minutes time. You can write up the detailed solution when I show you the solution on screen. Right now you can solve it as a rough work. I am giving you 5 minutes time and your time starts now. Alright friends, I have given you 5 minutes time and your time is over. Let me now read out the same for you. An energy company claims that the average monthly utility bill for household in a certain city is $150. A consumer rights group suspects that the actual average monthly bill is less than the claim amount. To test this, the group collects a sample of 50 households and decides to perform a hypothesis test at 5% significance level. So first thing what you need to do is you have to identify your null and alternate hypothesis, identify the type of test and determine the rejection regions. First of all, as I have explained to you earlier, how do you start? How do you begin? You begin not with H0, even though you may find that in many books and many contents you will be finding that H0 mentioned first, but by your thought process you should always think of H1 first. Now the company's claim is H0 and the claim of the consumer right group who is placing the suspicion is H1. What is that they are suspecting? That the average monthly bill is less than the claimed amount. Claimed amount is $150. So we will conclude that H1 states mu less than $150. So H0 will be formulated accordingly, that H0 will be stated as mu greater than or equal to $150. So let's begin with that part of the solution first. So in your solution, you first write the heading identifying H0 and H1. First you understand the claim. The energy company claims that the average monthly utility bill for household is $150. This is the benchmark against which the consumer rights group will measure their findings. Identify the consumers group suspicion. The consumer rights group suspects that the actual average monthly bill might be less than the claimed $150. The suspicion suggests that they are looking for evidence that the average bill is lower than what the company claims. Now before I take you any further, I want you to write this part quickly. Alright friends, once you have completed writing this whole thing, let us move ahead and continue further. Formulate the alternate hypothesis. Since the consumer rights group believes that the average monthly bill is less than the company's claim, the alternative hypothesis H1 should reflect this belief. H1 states that the average monthly utility bill is less than $150. So H1 states mu less than $150. Now based on that you will formulate the null hypothesis. The null hypothesis H0 is the opposite of the alternative hypothesis. It assumes that the company's claim is correct, meaning that the average monthly bill is $150 or more. So H0 will be stated as mu greater than or equal to $150. So please write up this as well and then I take you ahead. Alright friends, once you have completed writing this much, let us move ahead and continue further. Identify the test type. Because the consumer rights group is testing whether the average monthly bill is less than $150, this is a left-tailed test. Determine the rejection regions, significance level or alpha. The significance level given is as 5%, representing the probability of rejecting the null hypothesis when it is actually true. Left tail test rejection regions. Since it is a left tail test, the entire 5% significance level is placed in the left tail of the normal distribution. So first write this whole thing and then I take you ahead. Alright friends, once you have completed writing this whole thing, let us move ahead and continue further. Standard normal distribution. Here mu is equal to 150. Now, because you are having alternate hypothesis on the left side, it's a left tail test, so the critical region will be lying in the left. So if the utility bill is lower than $150 but not significantly lower, that is, it is falling in this range and not significantly lower, then you will not be able to reject the null hypothesis. But if it is falling in this region where we have shown red markings, means the utility bill is lower than $150 and significantly lower, so this becomes the rejection region. So the area marked with blue will be the area where we fail to reject the null hypothesis. Area marked with red is the area where we will be finding enough evidence to reject the null hypothesis. This area is 5%, so the other area will have to be 95%. Now we are talking about the critical values. So what will be the critical values? Now one thing is clear. If you can recall in the earlier example, with 5% significance level as a right tail test on this side, we have figured out that for 5% significance level, the Z value was positive 1.645. So in the same way, on the left side, we don't have to again and again check it from the Z table, and anyway Z table doesn't provide you the negative values of Z. It only gives you one-sided values of Z that are positive values. So, but because the curve is symmetric, what you find on the right will be the same thing on the left, but the signs will be different. So here it will be negative 1.645. So you write critical value of Z as negative 1.645. So if the test statistic falls in this region, means it is even lower than negative 1.645, you reject the null hypothesis. Otherwise, you fail to reject the null hypothesis. So please write up this whole thing and then I take you ahead.